Namaste student. Today we are going to see the chapter that is a polygon and their types. So here the polygon means a simple closed figure made up of line segment. That means if we take a line segment and join them, if we make a line segment, join them, you can see that this is a simple and it is a closed. Or if we take this type of figure, join them, this is your polygon. And if we take a circle is not a polygon. Yes, it is a simple closed curve, but it is not made up of line segment. If the figure which are made up of line segment and it is a simple closed curve, then we call polygon. Remember, if we take this one, join them, you can see these are made up of line segment, but you can see that it is not a simple. You can see that there is a nose. We call this nose intersecting. See here, two curves make each other here, then the whole thing is not a polygon. Yes, if you take this part and if you take this one separately, then you can say that it's a polygon. But if you take the whole figure, then it is non-polygon. Why? Because it is not a simple, it is a complex. So we will not discuss about the complex right now, just to really go for your polygon. So there are many polygons, but we have in our syllabus 10 polygons, like for starting with a triangle. For 3-sided polygon is called triangle, 4-sided polygon is called quadrilateral, 5 pentagon, hexagon, heptagon, that is 7-sided, sometimes we call septagon also, octagon, 8-sided, nonagon, decagon, dodecagon, undecagon is up there are so many guns, but up to 10 we have. And now, this polygon divided into two parts, one is convex, another is concave. So very simple definition, convex and concave. Now if you take one figure, check this one, and another will take like this, or you can take like this. Okay, this is L. Okay, made up of line segment. So this three figure is a polygon. Why? Because this is simple and made up of line segment, closed curve. Remember. Now two types. One is concave, one is convex. So if I ask you to identify which one is concave, so your answer is this one and this one, and convex this one. Why? For convex, remember, for convex, you need to check what? You take any two points anywhere and join them with a line segment. And if you see that line segment is inside of that one, then this type of figure we call convex polygon. Now for this one, if you take if I take this one, yes, it is a line segment, but you are getting at least. You need to get at least one point such that which is what? Outside of the line segment figure. That means this is your line segment which is the middle part is outside of your figure. Then that type of figure we call concave. Like if you enter into this one, you take one point here and you take one point and join them, you can see that this one is outside of the figure. That means is the concave. So your very simple definition is there in the book. But they are saying that concave, a polygon in which at least one angle is more than 180 degree. One angle is more than 180 degree. Then it is called concave polygon. Very simple definition. How? So if you see here, these are the interior angle, and look at this angle. This is more than your 180 degree. This is another definition. You need to look at it. More than 180 degree. So if your any one, at least one angle, maybe more than that. At least one interior angle more than 180 degree, then that type of figure is called concave polygon. Okay, and here each angle must be inside interior angle must be less than 180 degree. Then that type of figure we call, that type of polygon, not figure, that type of polygon we call convex polygon. Now in convex polygon, we are going to see two parts. One is regular polygon, another is irregular polygon. Regular means each angle and each side must be equal. Like quadrilateral, if you see, there is a square. In the square, each side is equal to one another and each angle is 90 degree. So that is your square is a regular polygon. Rectangle is not a regular, because in rectangle you can see that each angle are equal to 90 degree, but opposite sides are equal. All angles are not equal. And if you take rhombus also, and opposite all sides are equal, but angles are not 90 degree or not equals to each other. That means square is a special case. Similarly, in triangle also, there is an equilateral triangle. All sides are equal and all angles are equal to each other, that is a 60 degree. So equilateral triangle is one example and square is the example of your regular quadrilateral. Now what about your pentagon? So in pentagon we don't have any special name. So if I say the pentagon, that means it is a normal pentagon. It may be regular, it may be irregular. Now if I say the regular polygon, regular pentagon, that means each angle and each side must be equal. Now we are going to see there are some formulas. Here we have some formulas. So for this one you can see the arrow part, the regular polygon. That means first we need to know that sum of interior angles. Sum of interior angle is convex polygon. Sum of interior angle, because this one is the sum of interior angle. You can see that arrow is there for regular also and for irregular also. This formula for valid for convex. So we go for the convex. First one is sum of all exterior angles 360 degree. That means if you take one triangle and if you find these are your exterior angle, this is your exterior angle for this one, and if you take quadrilateral, so if you find here, you can see this is your exterior angle. And now if you add 1, 2, 3, 4, and if here also if you add 1, 2, 3, so angle 1 plus angle 2 plus angle 3, if you add 360 degree, remember, outside triangle. And for quadrilateral also, angle 1 plus angle 2 plus angle 3 plus angle 4, you will get 360 degree. This means if you take pentagon also, if you take pentagon and if you find exterior angle, this is your exterior angle, this is exterior angle, these are exterior angle, and if you add them, that means 1, 2, 3, 4, 5. If you add them, you will get 360 degree. That means whatever polygon, whatever convex polygon, remember convex polygon, whatever convex polygon, if you add the exterior angle, will always get 360 degree. It is fixed, remember. Now, if it is regular, remember, if it is regular, then you can find each exterior angle. How? By using this one, 360 by n. N is what? Number of side. Like if I am going to find sum of exterior angle, how will you find? That is 360 and divide it by 5. You will get your answer. Okay. So now, next one we will do, that is the sum of interior. Like if you see the triangle, we have angles of property. So angles of property, what? Sum of angles of a triangle is 180 degree. So how did we get that? Using this formula, that is n minus 2 into 180 degree. And means what? Number of side of that regular, not regular, convex polygon. It may be regular, it may be irregular. Now, if I take triangle have 3 sides. That means angle will be what? You can find that is your 3 minus 2 into 180 degree. Will get here 1 into 180 degree. Will get here 180 degree. That is for triangle 180 degree. Interior. Remember, interior changes. Exterior remain fixed. Now, for 4-sided polygon, regular polygon, that is a convex. So if you see here, that is 4 minus 2 into 180. That means 4 minus 2, that is 2. 2 into 180, you will get 360. For pentagon, that is 5. That is 5 minus 3 into 180 degree. How many? 400. Sorry, not 400, 540. And if we go for 6, that is 6 minus 3. Oh, sorry, not minus 3, that's 2, which remains same. And minus 2, fixed, will not change here. That means what? 4. 4 into this one will get here 720. So this way you can find exterior angle of convex polygon. And if it is, remember, if it is regular, then only you can find each interior angle. Otherwise you cannot find separately interior angle. Sum of all interior angle you can find, that is n minus 2 into 180 degree. And to find each interior angle, your polygon must be regular. Then only you can use the same concept, the way we have used 360 minus n. Here also, that is what? Exterior angle, total exterior angle by n. And here also total interior angle by number of side. That means n minus 2 into 180 degree by n. This is one formula. Another formula is also there, that is your 180 minus each interior, each exterior angle. Same formula. From here only I have read this one. So these are there. And one more topic is there, that is a diagonal. So we'll try to understand what does it mean that diagonal. Diagonal, we'll try to understand what is diagonal. So diagonal is line segment joining by two non-adjacent vertex. So adjacent means you take this one particularly. So these are adjacent vertex. Will not take adjacent vertex, and which are not adjacent. So this is, if you write like A, B, C, D, then your A or B are adjacent, A, D are adjacent, B, C are adjacent, B, A are adjacent. So will not take adjacent vertex. Just will take your non-adjacent vertex, and then we join them. We will join whatever line segment we get. That line segment is called diagonal or diagonals. Okay. Now, if you take Pentagon here, so diagonal how you will find? So here, non-adjacent, so we cannot go for this one. Here also, if you join here and more, yes, this is. So there we have one formula, that is what we have, n into n minus 3. So here you need to count here. If you take a hexagon, it will take more. If you go for a octagon, there will be more diagonals. So without drawing the diagonals, directly you can find the number of diagonals in the polygon. So here we have the formula n into n minus 3 by 2. This is your number of diagonals of a n-sided polygon. So for quadrilateral, check here, quadrilateral is 4 into 4 minus 3 by 2. So we are getting what? 4 minus 3, 1, and 2, 2 that means we are getting here 2. So number of diagonals in quadrilateral is 2. We can count 1, 2. Now let's go for the pentagon. Here we need 5. Here we have 5. So 5 minus 3, that is we will get here 2, and 2 cancel, we will get here 5. So if you count here 1, 2, 3, 4, 5. So there are 5 pentagon, and for 5 diagonals in a pentagon. This way you can find the diagonals, number of diagonals in a n-sided polygon. I hope you people have understood. Thank you very much.